Howdy, AP PreCal. It is Ms. Kosh. We are now looking at this problem that requires us to use our calculator. Okay, so at our school, we really like the Casio. TI can do all this stuff, but Casio does it a little bit better in my opinion, but here anyway. I have already typed this equation in, and what I did initially is I went Shift Window and I just hit Standard. So sometimes I'll start here with this window just so I can see what's happening, and then if I decide I don't like it, then I can go back and change it. So if I hit Draw or Enter, I guess I need to hit Draw. Here comes that little polynomial. And to be honest with you, I think that I need to zoom in a little bit more because I can't quite tell what's happening on this part of my graph. So I'm going to come to my window. The x values are fine. I could come in, but I don't have to. But the y values are a little too, maybe I'll go from -2 to 2, which seems a little excessive, but I just really want to know what's happening there around the origin. Not the origin, the x-axis. I was testing you. Okay, so notice, that's not even, I think I can do better. Let's go to the window. Let's make it from -1 to 1. I just want to be very clear. Is it bouncing? Is it not? Okay, and so here's what I see. I see it's passing through, bouncing. Okay, so let's see. G solve. I'm going to go for the roots. And my calculator, the nice thing about the Casio is you don't have to tell them where to look, but the TI, I think you do, or at least you used to. So I have a 0. The first one was -3. It had a multiplicity of 1. The next one here, we have a 0 of x equals 1. It also had a multiplicity of 1, okay? And then I can come over here to this third one. It's at x equals 2, but notice there's a bounce there. And so this has a multiplicity of 2. And I know that 1 plus 1 plus 2 is equal to 4. And so this can't be 4 or 6 or whatever because all of these, okay, so it was 1, 1, and 2, and that adds up to 4. Okay, so find all extrema with my calculator. Notice on this one it is even, and it's got a positive leading coefficient, so that tells me that it will have an absolute minimum. Okay, so G solve. We can do max first, whatever. Did I hit the button? Oh, okay, exit. And so this one, as I was working through my answer key, I realized I didn't ask this question in a nice way. Find all extrema. So sometimes they'll say find the maximum value. If they ask for the maximum value, then we want to know the y value. If they say find the location of the extrema, then we want to know the x value. So find all extrema with your calculator, indicate if they are local or global. So I wasn't thinking in terms of how I wanted you to answer this. So let me think of find the location of all extrema. Okay, so we have 1 when x is approximately equal to. My colleague who graded AP tests forever and ever and has now retired, he would suggest that we always just round to 4 decimal places. And so this had a multiplicity, that's not what we're asking. Local or global, this was a local, and that was a local max. Okay, and then let's do a G solve. Let's come and find minimums. And with my calculator, I don't have to be able to see the minimum, but I have to be able to see the x value, but I don't have to be able to see the y. And so when x is approximately -1.8508, I have an absolute minimum. And then I can scroll over because there's another one. And that other one is okay, so now I have at x equals 2, I have a local minimum. Super. Okay, the last one, evaluate f of 5 with your calculator. So the Casio lets me do G solve and then come over to YCal. And it lets me type in, okay, so I want to know what's the y value when x is equal to 5. So f of 5 is going to be equal to 28.8. That's not the only way to do that. I could come back, I could go menu and go over to table. And then I can just hit table and I could type in, I could override that 5 and there's that value. But there we go. Okay, let's see. Let's keep going. So the last part of our notes for today is going to deal with finding complex zeros and that sort of stuff. So on this one, I already factored it for you. So here's here's a nice rational zero. And this one we're going to have to, well, okay. I know that I can set this equal to 0, and I get x equals 4 is a 0. And I know I can set this equal to 0. Hopefully you've reviewed your quadratics. My favorite way to do this, because I know this doesn't factor, I much prefer to complete the square than do the quadratic formula. But I'm not going to stop you. I just watch how easy this is. Half of 6 is 3. It's half of negative 6 is negative 3 squared. Negative 3 squared gives a 9 in my box. This gives me negative 4. And now, for those of you in my room, we go square root, plus minus. And so I have x minus 3 is equal to plus or minus the square root of negative 4. Well, hopefully you know that the square root of negative 4 is 2i. And when I add 3, I have x is equal to 3 plus or minus 2i. Okay, you'll notice that it's 3 plus 2i and it's also 3 minus 2i. We call those conjugates, okay? And so the final answer is, what are my zeros? X equals 4 and x equals 3 plus or minus 2i. We typically think of conjugates in the form a plus or minus bi, like that, where this is the real part and this is the imaginary part. Super. Okay, so now they're giving us zeros and they want us to write an equation and they want us to expand it out. Okay, so they're telling us it has rational coefficients, but you'll notice that I have an irrational value here. So if I just were to say, okay, p of x is equal to x minus 1 times x minus, what is this, 2 plus root 3. If I just said, okay, it's only got those two, but I try and FOIL things out, I'm going to keep this nasty this nasty root 3 in my problem, which gives me irrational coefficients. So this guy has to travel with a buddy, okay? And so it's going to travel with the conjugate like this. So it's x minus, one of them was 2 plus root 3, the other one was 2 minus root 3. And now we have a few options for how to solve this problem. And did I show that? Well, my favorite, well, one, you could just FOIL all this mess out and it's gross. The other is that you could regroup things, and then it's a plus b times a minus b. The next one is you can recognize the sum of the roots is equal, I always forget it, so that one I don't recommend. But there's basically the sum of the roots. See, I forget it. I'll try and link to the video where I teach all three of these a little bit differently. But my favorite way I learned from Mr. Balin over at CHS 9, and that is set this equal to the 0, to one of them, it doesn't matter which one, and get the messy part by itself. So in this case, it's the irrational part, and this one it'll be the non-real part by itself, and then we just square both sides. And this gives me x squared minus 4x plus 4 is equal to the square root of 3 squared is just 3. And now I'm going to solve that, set this equal to 0, so I can subtract away 3. And that gives me plus 1 equals 0. So I kind of worked backwards from the root to get to this quadratic. So now my polynomial is x minus 1 times, now a quadratic, x squared minus 4x plus 1. The way I like to do to show this next step is I'm going to multiply everybody by x. Now I'm going to multiply everybody by negative 1, and I'm going to line it up so that my like terms match. And then I'm going to add my columns. And so my final answer, p of x is equal to, I had 1x cubed, I have minus 5x squared, I have plus 5x, and I have minus 1. The next one behaves in almost an identical manner, and actually I set it up in such a way that it's almost identical. But this one is, which I didn't mean to do, but I did. X plus 2 is going to get multiplied because it's minus the 0. X minus, one of them is 2 minus I, the other one becomes an x minus 2 plus I. I don't have to write that out if I don't really want to, because what I'm going to do is I'm going to set it equal to that 0 that they gave me. I'm going to keep the imaginary part on one side, put the real part with this. So x minus 2 equals negative I. See what I mean? I just did the same thing. I didn't mean to make them the same, but whatever. Square that. I have x squared minus 4x plus 4 is equal to the negative squares and becomes positive, but this becomes an I squared. And hopefully you know that I squared is equal to negative 1. X squared minus 4x plus 4 is equal to negative 1, add 1, and I get, this is now x plus 2 times x squared minus 4x plus, this moved over and became a 5. Life is good. Okay, let's do the same. I like to line everything up. X cubed minus 4x squared plus 5x, then 2, positive 2x squared, negative 8x. By the way, I keep making mistakes this year, so if you find any, let me know, but tell me nicely. Got it? Okay. And then we have this is our new polynomial. All right. Like, subscribe, comment, all the things, and go practice. Good luck to you.